Okay. Assalamualaikum dan selamat pagi, good morning pada semua. We are on Wednesday morning, pukul 11 pagi, 30 hari bulan March, 30th of March. We are still in the topic of staircase. Hopefully we can wrap everything up by today. Dan tomorrow we'll be having our discussion on project work, which will be on 8:30, 8:30 pagi besok. We'll be discussing more kepada project work because we are now in week number 2, belum lagi ada discussion on the project. So insyaAllah by tomorrow morning we'll be looking at project work, RC2 project work. Okay, that will come tomorrow at around 8:30. So I'll share the link later on. So for today, we'll be continuing our class on Monday from where we left off. Mana di kelas? Saya baru habis kelas IDP Earthwork ni. Tu yang pening kepala sikit ni. Confused, cari tak jumpa. Sekejap. If I'm not mistaken, we were discussing, the last discussion was on, sekejap ni silap drawing ni. Design of staircase. Okay. Ni baru betul. Alright. We were discussing more kepada the third example. Example number 3. Hopefully semua nampak what I'm sharing there. It is the example number 3 where we were discussing last Monday regarding staircase being supported by landing. I think that was the main point that we were discussing last Monday. We now have a case where staircase is being supported by landing, disokong oleh pelantar, tangga disokong oleh pelantar. Now this problem comes about by by virtue of the sketches given di sini, the 2 sketches. The first sketch is the plan view, dan the second sketch is the cross-sectional view. Now what gives away immediately ialah kalau kita lihat pada cross-sectional view is that particularly between the landing beam, ini saya selalu namakan dia sebagai landing beam, the beam located pada landing, tapi this is not exactly landing beam because this beam, this particular beam is not connected kepada the landing pada landing. So this is the first main criteria yang that we can observe from the cross-section view, that there is a beam located at the end of the landing. However, the beam is not connected kepada landing, which means that pada this flight of staircase, pada this particular staircase yang ini, for this particular staircase, we are now short of one support. We have one support di sini. Clearly there is a support di sini, but because the beam is not supporting connected pada landing, maka we lose another support di hujung sini. There is no support at the right hand corner of the landing. There is no support. So this particular staircase has now become a staircase of insufficient support. Hanya ada satu sahaja. And we all know that whenever a beam has only one support, it becomes unstable. It is an unstable punya element, and therefore we can conclude yang this particular staircase is a secondary staircase, tangga kedua. It has to depend on something else to support the staircase because there is no connection between beam di sini, maka it cannot depend on this particular beam. It has to depend on something else. So it becomes a secondary support. The staircase itself hanya ada satu penyokong, which is this particular support. Okay, so this is the cross-section view that we can see. Dia punya clear indication of the problem that we are facing. Okay, kemudian from the plan view, okay, The plan view indicates again, okay, kalau kita tengok ni, there is a gap between this particular landing and this beam dengan landing ni, okay, as confirmed by this gap di sini. Sebab maybe 50 mm ke 2 inci ke gap, okay, and this is indicated by the double line kat sini. Kemudian another observation ialah from the plan view, now we are looking at a case yang mana there is a dotted line di sini. Dotted line, and this dotted line belongs to the beam yang di sini. This particular beam, and it indicates bila ada dotted line tu, it indicates that dua beam ni, these two particular beams, left hand side and right hand side of the landing, is now connected directly kepada landing. Meaning to say that we have a landing, kalau saya make cross section view, we have a landing, and then kita ada beam at the end of the landing. Okay, connected kepada landing as indicated by the dotted line. Okay, as indicated by the dotted line, kita ada another beam di sini. So in this case, the landing is now a complete structure, meaning that we can idealize the landing ni sahaja sebagai a simply supported beam. Okay, as a simply supported beam. Okay, this is our landing, and then kita ada dua penyokong di sini, two supports. So we can idealize the landing sebagai a beam element with two supports, making this the first simply supported case yang kita jumpa. Dari example 1 and 2, it was a continuous punya staircase. Now we are looking at the first simply supported punya condition, and it happens to be landing yang simply supported. Okay, so when landing is simply supported dan tangga di bawah tadi, this particular staircase, okay, tangga tadi is short of one support, this particular staircase yang ini, staircase yang ini, dan juga this staircase, okay, short of one support, maka now the landing will behave sebagai penyokong kepada tangga. Okay. Landing ada dua penyokong, tangga ada satu penyokong, handicapped by one. So the staircase is now considered to be a secondary element, whereas the landing will now be the primary element. So it becomes clear at this stage that we're dealing with a case where we have a staircase, where the staircase is supported by beam on one side and supported by landing on the other side. So we have a case where a staircase is now clearly supported by a landing. Alright, hopefully everyone dapat pegang pada that explanation, that now we are doing a case where a staircase is now supported by landing. And because staircase tu supported by landing, bermakna landing sebagai penyokong, okay, menyokong tangga, landing as a support to the staircase. Therefore, in terms of design, we need to separate antara dua ni. Because one is major, satu lagi secondary, minor. So we cannot combine both major and minor into a single design. We need to separate between the major and minor. And this is what happens when we stop our last discussion last Monday, that saya highlighted that we need to differentiate between the two designs. We now have satu design on major component, which is the staircase, which is the landing, and satu lagi minor design, which is design on a minor element, which is the staircase. And remember, bila kita ada major minor, okay, major supporting minor, okay, that's the case lah kan, major supporting minor, landing supporting tangga. If that is the case, then when we are designing the major component, which is the landing, then be sure to add the resultant forces ataupun the reaction from the staircase acting pada landing, because landing is a major, staircase is the minor. So whatever reaction from the whatever loading pada staircase will now be translated sebagai reaction pada major. So now we have a case of loading from staircase ataupun reaction from staircase transferred kepada tangga. And that is one very crucial aspect when we are dealing with staircase yang mana, ialah sebenarnya when we look at example 1, example 2 pun, okay, if saya minta design the beam supporting the staircase, pun sama juga, you still need to calculate the reaction. Cuma dalam contoh 1 and 2 tak ada pun mention design the beam. Example number 2 contoh. Example number 2 is where we had apa nama landing, kemudian beam kat ujung sini. Now, nowhere in the solution did we design this beam. Kita tak design pun rasuk ni. Tapi in actual fact, we still need to design the beam. Kalau betul-betul lah. Because tajuk ni tajuk tangga. So we're concentrating on the staircase kan. But in normal case, when you design a building, you still need to design the landing beam. Beam kat ini. Kita masih perlu reka bentuk. And this beam will, because this beam is supporting the staircase, maka akan ada reaction daripada staircase pada beam. Okay. Cuma dalam contoh lepas, we are not looking into the beam design. So we stop di situ saja, staircase saja. Now, this landing ni is behaving sama macam beam ni. It is now becoming a support, penyokong. Tapi because it's not a beam, it's a landing. Therefore, we need to design the landing. Yeah? Jadi contohnya di sini ialah what I'm trying to stress out is that in actual fact, we still need to design beams pada example 1, example 2. Cuma in the examples, previous example, we were focusing more pada tangga sahaja. If we were to design the beams, then the reaction from the staircase kepada beam will need to be considered. Sama macam our discussion yang ini. Because the landing is now behaving sebagai support, therefore to design the landing, the reaction from the staircase has to be considered dalam landing. The same principle applies. Cuma dalam previous example, kita tak design the beam. We were not we were not designing the beams. We were just designing staircase saja. If we were to design the beams, macam dalam project nanti, then you need to calculate apa reaction ni. What is the reaction on this particular beam? What will be the reaction ni? And this reaction will come from the staircase. Okay. The shear force daripada staircase tu, itulah reaction pada beam. Okay. The same principle apply. So we move on kepada our example. Now kita look into the actual calculation. That is the concept yang kita faham. Now the staircase is being supported by landing. We need two different designs. Satu design for staircase, another design for landing. And the most important part is that the reaction from the staircase has now to be considered dalam landing before we design the landing. The major component supporting the secondary component. Therefore, reaction from secondary component has to be considered dalam major component. Itu sajalah. Basically, that is the case, the direction of our solution. Right. So, looking at these two schematics, kemudian these are the data given, the permanent GK excluding the self-weight, variable load given, okay, dan sebagainya. Maka, as usual, untuk bahagian tangga, okay, we still need to get the reaction di sini. Okay. For the staircase sahaja, we can model bahagian tangga sahaja as something like this. This will be our model. This is somewhere center line. Okay. This will be my center line of the landing. Remember, landing is 1.5 meters. This is approximately 750. Dari tepi sampai sini. This is approximately 750. 750. This is my center line for landing. Okay. Because landing is the support. So I'm measuring ataupun I'm taking center line of support. So center line of support is center line of landing. The landing is 1.5 meters. Okay. The landing is given dalam this view, okay, is 1.5 meters. That is the width of the landing. So I'm taking 750 as my center line. Okay. So now I have my supports di sini. Okay. My blue support, pakai biru lah. Blue support. That's my support. I have one support over here representing the beam di bawah ni. And another support di sini representing the center line of the landing. So the landing is now becoming a support. So ini dua support. So in terms of loading, okay, in terms of loading, I just like to highlight bahawa because landing ni separate design, maka GK and QK pada landing will have its own GK and QK. Therefore, loading pada tangga ni will only be considered until sampai sini saja. This will be the GKs and the QKs pada landing based on 1.35 GK dan sebagainya. Then this will be the loading pada tangga. It will start from one end at the center of the support sebelah kiri sehingga kepada line 750. So the rest of the loading 750 ni zero. Okay. Beyond the line of 750, there is absolutely no loading. Sebab whatever load pada landing sini, pada zone landing di sini, whatever load on top of this landing will appear dalam landing punya analysis. Remember kita punya landing previously, we have a landing, kemudian we have a beam support kat ujung sini. Okay. At both ends there is a beam support for the landing. This is one end, and satu lagi, another end dia pun there is another beam. Okay. So whatever loading pada landing ni, whatever GK dengan QK will appear only pada landing sini. So the loading sini, the GK dengan QK ni is based on landing punya loading, self weight of landing, kemudian QK pada landing. So that is why zero loading kat sini. Tak ada loading. All loading will appear di sini dalam landing punya schematic. Cuma this reaction, okay, once we determine what will be this reaction will then be added kepada sini. Reaction ni pun ialah nampak macam point load di sini, tapi sebenarnya it is a UDL load kilonewton per meter, okay, per meter width of the staircase. So this rate loading ni sebenarnya adalah reaction, katalah V from the staircase ni, this is the V. The GK and QK from landing plus the V barulah dapat total load acting pada landing. Because landing is supporting staircase. Ini yang dimaksudkan the reaction from the staircase transfer kepada landing, right? So to obtain kita punya GK dengan QK ni lah, that is the reason why kita ada this schematic ni untuk dapatkan dia punya average thickness, because we want the GK dengan QK ataupun the beban mereka bentuk pada tangga tu. So from here kita dapatlah yang ini pada landing, yang ini pada tangga, for the staircase. Okay. We have average thickness of 264, which gives us 6.61 kilonewton per square meter GK self weight, plus kita punya finishes, a total net permanent load of 7.8, whereas we have a net QK of 3.0, giving us a 1.35 GK plus 1.5 QK for the flight untuk tangga to be approximately about 15 kilonewton per square meter ataupun 15 kilonewton per meter for every 1 meter width of the staircase. Now this is the loading daripada tangga. Dan daripada tangga ni, okay, this is the case. This is the loading. Ini yang dimasukkan 15.1 ni ataupun lebih kurang 15 ni. This is the loading. Sehingga kepada this level. Then kita calculate what is this reaction. This reaction nanti will then be added kepada kita punya landing. Okay. Dan kalau dilihat, this is the typical loading condition. Okay. F would be W1 times L1, W1 by L1. Dapatlah nilai F. Kemudian dari situ dapatlah FL over 10. This L referring pada overall span, effective span. Maka dapatlah kita punya total moment pada negatif dan juga positif. It's approximately 14 kilonewton meter per meter width of the staircase. Right? So kalau kita tengok balik pada dia punya reaction pula, shear force. This is the loading reaction dia, 11.8. Okay. So this 11.8 ni adalah reaction from support. Tak ditunjukkan sini. You need to do your own calculation. So the value di sini ialah approximately 11.8 kilonewton per meter width of the staircase. Due to the loading yang kita bincang tadi, which is approximately tadi 15, okay? And then from there kita dapat bending moment and all those things. And then from there kita dapatlah dia punya free body diagram and we can evaluate what is the shear force. Ini 11.8. So take note, this 11.8 adalah reaction. This 11.8 nanti will be added kepada landing. Landing tak tengok lagi kan? So kalau kita tengok landing, we have a look at the landing. Mana dia? Right. Ini landing. Landing punya loading is approximately 11.2, which comes from 1.35 GK dengan QK acting pada landing sahaja. Okay, only pada landing sahaja. We're not talking about the staircase, we're talking about the landing. And the landing is 150 mm thick, 150 mm, giving us our self weight plus services to be approximately 5 kilonewton per square meter. QK sama 3, and this gives us a design load of 11.18. So kalau tengok sini, for the landing di sini, the W nya ni, mana dia? Ni, okay. So loading, total loading pada landing adalah GKQK for the landing plus reaction daripada tangga which is 11.8. To get the loading daripada pada landing sama je. Kalau tengok sini loading dia tengok ni tangga light landing. Self weight 3.75, kemudian finishes 1.2, total GK 4.95, total QK given as 3, total design load 11.18 kilonewton per meter width. So this value is now 11.18. So yang ini 11.18. Biasa kenapa pula darab 1.5? Remember this 11.18, this value of 11.18 ini adalah unit dia kilonewton per square meter. The unit for the load yang kita calculate earlier acting pada bahagian landing sahaja is 11.18. The unit is kilonewton per square meter. Right. Now, looking at the floor, the plan view, kalau kita tengok plan view of the drawing, sketch dia, okay. Bermakna loading yang asal is 11.18 kilonewton per meter square pada landing. Now, my reaction tindak balas daripada tangga, okay, from the staircase, saya tu lukiskan dengan warna biru ni. The blue indicates my reaction ataupun shear force coming from the staircase. Ini tindak balas. Sorry. Lebih kurang patut buat tengah-tengah. Okay. somewhere in the middle. Sebab kita punya ini is di tengah-tengah. Ni. Straight line, mana straight line. Okay. This is my loading. Ataupun my reaction from staircase 11.8. Ini yang 11.8 tu. The shear force 11.8. This is the reaction coming from staircase. Ini adalah 11.18. Ini 11.8. Ini 11.18 is the load, design load pada tangga, pada staircase. So to have my design load dalam direction yang sama, if I want my design load to be in this direction, okay, dengan loading macam ni, my design load, maka my 11.18 tadi, 11.18 must now be multiplied by lebar W. Darab dengan W, barulah dapat kilonewton per meter sepanjang span of the landing. Okay, so saya ulang balik. The original load on the landing is in kilonewton per square meter, but we want the loading to be along the length of the landing. That is why we multiply by the width of the landing, which happens to be about 1.5. Which is the width of the landing. So this width of the landing is 1.5. Maka that is the reason why 11.18 itu darabkan dengan multiply by 1.5, so that now we have load pada landing in this direction. Kilonewton per meter width along the landing. Dan direction yang biru dengan merah ni is in the same direction. Barulah kita campurkan. Then we add these two values together. Okay. And that is what we see dalam solution. Okay. This solution, landing, flight, okay. Landing. This is what we see di sini. Loading daripada landing is actually kilonewton per meter squared. 11.18 ni is the design load on the landing. Multiply by the width of the landing supaya dapat kilonewton per meter length of the landing. Sama direction with the reaction from the support. Adding these two together, maka we have a total loading ataupun total weight of 28.6, which is the self weight GK dengan QK of the landing plus reaction daripada staircase. Dan daripada sini dapatlah the bending moment WL squared over 8, okay, or the shear, maximum shear WL over 2. Okay. Boleh faham? Ini design yang ditunjuk ni, this analysis is for landing. Concentrate pada landing. Okay. Dia tak tunjuk, is not shown the design of the staircase. The staircase punya design sebenarnya daripada sini dah boleh design. We know the bending moment is about 40. Then provide top reinforcement for 14 kilonewton meter per meter width and 14 kilonewton meter per meter width untuk sagging. So hogging dengan sagging dah ada. So sebenarnya we can design the staircase based on the data di sini. Tapi dalam example ni, dia skip the design, okay, skip the design dan terus pergi kepada landing sebab landing is the main component. Landing is supporting the staircase. Okay. So the bending moment untuk landing is based on a simply supported case. We are now looking at the first example where we have a simply supported component dalam tangga. Sebelum ni it was all continuous. Yeah. And I guess the rest of the solution is relatively quite similar kepada our previous discussion. Menggunakan beam theory, normal rectangular section, lebar 1 meter. Finally kita dapatlah cuma yang ini for the landing okay, it is bukan lagi per meter width, bukan lagi per meter lebar. So we are using moment kilonewton meter, shear force kilonewton point load, okay, bending moment kilonewton meter, which means the reinforcement is now millimeter squared sahaja. Bukan millimeter squared per meter. Ini dah silap. Jadi sepatutnya just millimeter squared sahaja. Millimeter squared sahaja. Yang ni dah tak ada dah. And based on 854 millimeter squared, maka we provide a reinforcement for the landing in terms of bilangan dengan diameter bar. Tak ada spacing. 17H10. 17H10 which gives a total area of 1335 millimeter squared sahaja, bukanlah per meter width. Ini dah tak ada per meter dah ni. There is no per meter dah sini. Just millimeter squared sahaja. Dah dapatlah 1335. Required is mana tadi? Required 900. 900 lebih kan? 854 provided 1335. Okay. 17H10. Balik kepada beam punya sign convention. Bilangan dengan diameter bar. Kalau slab, diameter bar dengan spacing. Millimeter squared per meter. Sekarang ni millimeter squared sahaja. Ada soalan?
Tak ada, Doktor.
Okay. Alright, so and then the rest of the solution ni sama je lah. We're looking at beam theory, dapat Dirichlet. Dirichlet ni coming from mana dia datang? Datangnya daripada sini. Okay. So V adalah WL over 2, simply supported. Bending moment WL squared over 8. And this is our shear force around 50 kN. Dan bila disemak, our maximum VRDC is 100 plus. 100 lebih. Our design shear force is approximately 50. So clearly it is safe against shear. Deflection criteria, kita dapati L over D allowable is about 28.7. Again, yang ini we have our L over D actual about 28.3. Terlalu hampir antara provided, L over D allowable dengan L over D actual. Too close, terlalu hampir. Bermakna the 150 mm thickness tu sebenarnya we can go for 175. Okay, 175. Kalau tengok dia punya span 3.4 meter. Untuk inilah untuk landing 3.4. L over D approximately 30. Dan daripada sini our D would approximately be equal to 3400 bahagi 30 divided by 30. Anyone? Yang ada calculator? What is 3400 bahagi 30?
113.
113. Okay. Azrita, 113. Terima kasih. 113. Okay. So 113 bermakna plus my cover about 20 mm ke 15 to 20 mm, dan maka cover is about 25 ke 35 ke. Maka I can choose to be around 150 or 175. Tapi daripada sini 150 menghasilkan solutionnya too close, terlalu hampir antara allowable dengan actual for deflection. Okay, deflection criteria, it is a bit too close. Yeah. However, it's still okay lah. In terms of kita punya on paper, it's still okay. Okay, cracking sebagaimana example 1 and example 2. Detailing tak ada. Detailing ni macam mana? Detailing. Mana saya nak buat ni? Saya pun dah lupa. Sebab bila kelas untuk IDP, Ada section yang sampai 60 student. So serentak 2 kelas, 2 section. Saya tak boleh nak guna Zoom because the number of students is more than 100. Paksalah guna Webex. Bila guna Webex itulah. Bila balik guna Zoom, saya pun akan cabut. I would prefer Zoom lagi daripada Webex. Okay, anyway. Untuk bahagian tangga. Kita ada 2 komponen, remember Untuk walaupun tak direka bentuk, we were not designing the staircase. We were designing cuma landing saja. Yeah? Anyway, if we were to design the staircase, kalau kita reka bentuk tangga, then our staircase would be the detailing for the staircase would look something like, remember kita ada landing, kemudian kita ada anak-anak tangga, okay? And then I have my landing sini, something macam ni. Even though we did not design the staircase, but basically the detailing for the staircase, because our bending moment, remember kita punya schematic for the staircase, okay, is something macam ni, and we had apa nama negative bending moment di sini, and a zero bending moment di sini. So the negative bending moment, we need top reinforcement. Therefore, untuk top reinforcement, I'm using yang ini. This will now be my top reinforcement. Okay. Followed by my bottom steel. All the way sampai sini. Okay, something macam ni. Straight line lah. Top steel sampai sini, and then bend up all the way sampai sini, and then okay. So the blue line ni is for my inilah bahagian bottom ataupun positive bending moment, bottom steel, okay. And then negative bending moment dia jadi top steel. Tapi it is insufficient. So I still need to have this black reinforcement ni is my reinforcement from my adjacent slab that is now anchored ke dalam staircase. It's not something that I designed. Okay, so the black dotted line indicates adjacent reinforcement in case ataupun anchored ke dalam tangga. So I still need to provide some additional reinforcement di sini, okay, to cover for my top reinforcement. Okay, sebab negatif sini. Yang ada top sebelah sini adalah cuma yang ni. Yang ni dah bukan top lagi. So I need to have my top reinforcement di sini. Top menjadi bottom, bottom jadi top. Something macam ni lah kot. The red reinforcement is the additional reinforcement that I need to add to cater for the top reinforcement. So pada penyokong sini, I have my top reinforcement on the right and top reinforcement on the left. Okay, this will now be my bottom reinforcement, and for anti-crack